Hello Legacy Sabers, Marsh here. So today we're going to look at parallelograms. What you're going to want to have on you today is the foldable that you made in class with me. You're going to want a calculator just to do some simple math, and then you're going to want a highlighter and color pencils to kind of draw on some of the diagrams today. You're going to want to grab out the quadrilaterals book that we made together in class, so go ahead and find that in your bag or in your notebook. So the very first thing, open up to the Parallelograms tab. So open up to this tab. It's kind of hiding on my picture, but open up to Parallelograms for me. So the very first thing that we want to talk about is, what is a parallelogram? What's the definition? Well, the definition of a parallelogram is a quadrilateral in which opposite sides are parallel. Okay? So basically what we know about a parallelogram is sides that are opposite of one another, aka ones that are not touching, if you want to consider that. Those are going to be parallel lines. So if I look at my diagram here of my parallelogram, this line right here would be parallel with this guy, and then this guy would be parallel with this guy. So what are some properties of a parallelogram? Well, opposite sides are parallel to one another, so they do not cross. Another thing, though, that opposite sides are, they are congruent. So bringing back that word that you learned about beginning of the year, remember congruence looks something like that. So I'm going to take my highlighter here. I'm going to mark in some congruent sides, so using right here. So this side right here, he would be congruent to his opposite side, so the other side of the parallelogram. The other group, so this side right here, he is parallel and congruent to that side. So keeping that in mind, guys, that these two sides, opposite sides, are congruent. Now, the yellow is not congruent to the green, only yellow is congruent to yellow. So also another way we could do this is with our pencil, we're going to mark in to show. You guys remember when you guys did the little tick marks to show you're congruent? That guy? Whoops. There we go. Another thing to look at, opposite angles. So angles that are diagonal to one another, if you want to consider that, those guys are congruent as well. There we go. Taking a little bit. So, my congruent angles, if I want to take out my highlighter here. So, opposite angles. These guys would be like this side, this would be an angle. And then this side over here would be my opposite angle as well to that. So notice how they're diagonal. Notice that both pieces have to be together to be congruent. Another pair of opposite angles that would be congruent would be this pair right here and then this guy over here. Whoops, not eraser. Pen. Consecutive angles. So angles on these sides, so this blue and the purple, they are supplementary. So that means, guys, that they add to, if you guys need to remember, 180 degrees. They add up to 180 degrees. Those are supplementary. So that would be, if you want to make a little note, for me it'd be blue plus purple equals 180. So these guys equal 180, these guys can equal 180, these guys equal 180. So whatever colors you colored in your angles, those would be the two that equal 180. Another thing, diagonals, they bisect each other. And if you want to remember what bisect means, that means cuts each other in half. So let's assume that if they meet at this point here in the middle, what that tells me is that this side right here is congruent or the same measure as the other side. So this side would be also the same measure as that guy. And it works both ways. So I can mark in this side here with this side here. So these two from here, this dot, the corner, to the middle has the same length as the middle dot to that corner. Same thing, I can do 4 slashes here to my 4 slashes there. So that's all the sides congruent for me in this particular parallelogram. Let's take a look at a couple of examples here. So, using our properties, if ABCD is a parallelogram, measure of angle A is x degrees and measure of D is 2x minus 3 degrees. Find the value of x. Let's actually draw this, shall we? So I'm going to draw my parallelogram here. Oops. Draw my parallelogram. There we go. A little bit rectangular-ish, but it should be okay. So they tell me A, B, C, D is a parallelogram, and they say angle A is x degrees, so I'm going to put that. Measure of angle D is 2x minus 3 degrees. Find the value of x. Well, I noticed something. If I look above, look back on my diagram here, notice we have these two measures, right? We have the blue and the purple going on, which I know supplementary angles are 180. That's the blue plus purple. So that tells me that if I take x plus that measure, 2x minus 3, those two have to be added up to give me 180. So let's go ahead and combine our x's here. So I have x plus 2x, that is a 3x, minus 3 equals 180 degrees. Let's add 3 to both sides. So I'll get 3x equals 183. I'll divide by 3, and I get x equals 61 degrees. So that one was just dealing with consecutive angles. If you have trouble identifying those C is for consecutive, and they make a C. If you want to see that, that makes kind of an easier way to point them out in case you miss them. So they give us in example 2, XYZW or XZW is a parallelogram with diagonals XZ and WYs or YW. So let's go ahead and draw our parallelogram here. So I got X, Y, Z, W, and I have diagonals, so X to Z, WY, and they intersect at a point A. So this is middle here, that's A. If XA is 3M, so XA. So this measurement right here has to be 3M. And this guy, Z to A, is 5M minus 4. I need to find M. Which one can I use? Let's look at our properties here. Well, I'm not talking about angles. I'm talking about my diagonals, right? And I know diagonals bisect each other, so I know they cut each other in half. So that must mean that this side of the diagonal is equal to that side of the diagonal. So what would tell me is that 3m is in fact equal to 5m minus 4. So let us subtract 5m because I'm going to get it to the same side of 3m. Just making a line down the middle there so I can see where my equal sign is on my equation. Those guys are going to cancel off. 3m minus 5m, that's negative 2m equals negative 4. Looks like I divided by negative 2. So I get m equals 2 for an answer. And let's try the third and final example here. So, What can I do? What can I do? What can I do? Well, I noticed something. I got this angle right here. He's 120. And I know, based on my properties, looking above, opposite angles are congruent, right? So that tells me that this angle right here, grab my highlighter, this guy, he has to be congruent to this guy. AKA, they have to be equal. So I know that Z has to have a 120 degree measurement. Just has to. Okay. What else can I do here? Well, another thing I know that I see a C, right? We got a C going on. So that would mean consecutive angles, which tells me that this guy, and that guy, because this 35 and X both make up that angle, right? Those guys have to be equal to 180. So what I should be able to do is go 120 plus 35 plus X equals 180. Let's add 120 and 35 together because they're on the same side. So that's 155 plus X equals 180. I'll subtract 155. So X equals 25. Okay. So this is 25 degrees. Excuse me. How can I find this last guy right here? Well, kind of go off to the sidebar here. If I have, because I know these sides are parallel, yes? So if I have parallel lines here, I'm just going to kind of extend my sides, and I have this transversal conveniently cutting through here. And I know this guy is 35 degrees. Notice that would be an alternate interior angle. And remember, alternate interior angles were congruent. So if he's 35 degrees, his pair over here, aka Y, have to also be 35 degrees. So don't forget about the ability to use your angle pairs as well. So I'll have a 35 degrees for Y. And that's the end of this video. See you later, Sabers.